Now, but that was the only reason why we used an array. Nevertheless, even though an array allows you to have random access anywhere, since we're playing with the stacks, and we're going to do everything from the point of view of the stack, we shouldn't be able to manipulate this directly. Okay? So all the user will be able to do is push, pop, to insert or remove elements. And additionally, pick just look what's in there. Right?
So can we peek all the way to the bottom or just to the top? That's it.
When you say pick, you always pick the last element that was inserted. So it will be the one on top if you want to see the stack like that. Right? Got it? And when you push, that means you're going to insert the element on the last position, on top of everybody. And when you pop, you can only pop the element that is on top, right? And then your element that is on top will be the next one, right? Is that clear?
Yeah.
Yes?
So we can constantly pop and to get the last one on the bottom.
Correct. If we're going to get the first element that was inserted, we will have to do all pops until the last pop will give us the first element that was inserted. Good. Is that clear?
Yep.
Yes?
So then you can write a code saying pop until you reach.
While stack is not empty, keep popping. The last element that you pop was the first element you inserted. That's it. Got it? So let's see. The push was very simple, right? Could you turn off the lights, any of you guys? The back? Thank you. So the push was very simple. We said if the size is less than capacity, then it is possible to insert. Correct? Otherwise, we say stack is full, sorry. If the size is less than capacity, size initially 0, right? So everything should be available, correct? So I'm going to say at position 0, put element n. I'm inserting and incrementing size to 1, meaning that I have one element. But that size that tells me 1, that I have one element, at the same time will be useful because that number, 1, will also indicate to me what's the next position to push the next element. Is that clear? Yes? If you see this like this, a stack like that, 0, 1, 2, 3, for example, size 0 means I have to insert it here. I inserted a position size. Correct? Say insert 7, right? And then I want to push. Say somebody tells me, imagine this was push 7, right? Now somebody tells me push 9. Size is, so far what? 1, right? So when I can push 9, I'll say, what's the size? Push the number at that position. So here, position 1. Got it? So size will have two functionalities here. The first one will tell me how many elements have been inserted. And the second one will tell me what's the next position to insert the element. Correct? Is that clear? Yes? Now, when popping, if I want to pop 7, sorry, if I want to pop 9, right? Because that's the only one I can pop directly, right? If I want to pop 7, I have to pop 9 first, right?
That's if it's being 2 or empty.
Correct. So that's why size is 1. If you push 9 down, size is 2. Got it? Now, if somebody tells me now, this happened first, this happened second, and now I want to pop third. Got it? Now, somebody tells me pop. The element that should be popped should be 9 because that was the last one that was pushed. Right? What should I do? If I return the element at position size, that will be wrong because size is here.
So it's
Correct?
going to do size minus minus.
So, so I have two options. I can say size minus minus. Marker. I can decrement the size because I'm going to pop 1. Right? Now that I have decremented, size contains the right position. Got it? Is that clear? So I should do what? Return, say the array is A at position size. Right? Is that clear? Yes? Now I did it differently here. I told I'm going to keep the original size and then decrement the size and then return the one at position original size minus 1. Same thing. Right? You know, maybe some of you don't like it, you were getting confused. You can just do this. Right? Same thing, right? Correct? size has been decremented, so now contains the position of the element that should have been popped. Correct? Is that clear, guys? All of you? Yes? Yes? Now, the array physical in memory still looks like this. After these three operations, the array still looks like that. Size is equal to 1. This is the information we have for the stack. Professor, but didn't you tell me that you removed, that you popped 9?
So you just popped out 9, so that's, what we said, that's a position.
What happens is that when you pop, you're not going to take it away from the array itself. All you're going to change is the size, because the size is the one that tells you how many spots have been occupied. So if size tells you 1, you understand that the only spot that is valid is one of them. Here there may be still a 9, but you ignore it because it's saying that size is 1. You got it? Is that clear?
Say that again one more time.
Size has been decremented to 1, but the array looks exactly the same as before. Correct? Now, has it been correctly popped? Yes. Because even though the data is there, it doesn't really matter. Because I'm saying size is 1. So I know that I don't care how many values are there. I know that only the first one is the one that is valid. Because it says size 1. Only one element is there. Got it? Yes.
So what happens if you increase the size, then that value is going to be there, and then you're going to access that, and you're going to see that
The size should never be modified
again.
directly.
Say that again?
The size, because here Alberto is saying, what if I want to say, for example, my stack set size to 2? Then the push is going to look for this guy, sorry, the pop is going to look for this guy the next time, and that's wrong because it was popped, right? That's what I'm saying. The size actually should never be modified by anybody except push and pop. Push and pop should be the only operations that modify size. Therefore, even though we have the attribute size in our stack, we are not going to put a setter for size, because otherwise we could make this stack inconsistent. Somebody could come and say, my stack set size 1,000. And I have 1,000 if my capacity is 4. No, right? So if I allow that set size to be there, anything can happen and the stack could be inconsistent. Is that clear? Yes? So the only ones that will modify size will be push and pop. The constructor puts size to 0 the first time when the stack is created, and then push will increment size as elements get inserted, and pop will increment size as elements are popped, right? Removed. Is that clear? Yes.
Question, what would you use push and pop for?
I'll give you an example in a second. I'll give you an example where we can use stacks in general. Okay? Is this clear?
So size 1 has now 7 in it?
Sorry?
Size 1 now has only 7 in it?
Size 1 now indicates you that even though the stack contains 4 spots, only the first spot is the one that contains an element. The rest are garbage.
Okay.
You guys are Java developers, and many of you have not been exposed to C or C++. And that's why you are used to that. When you create an array, everything is 0 at the beginning. And some of you, when you pop, you want to put a 0 here to indicate that this is empty. Right? But you don't need to do that. Because what if I push a 0? It will be confusing. Is it a 0 that was pushed, or is it a 0 that was removed? Right? That's why I don't care. I just use size to indicate which ones of all the elements are the ones that are valid. Get me? In C++, when you create an array, C++ doesn't put zeros there. It puts anything, random numbers. So the only way to indicate that this is good is with size. It is something new that I'm introducing. You use that all the time. How many of you use Windows? All of you have used Windows in your life, right? Same story with Linux, same story with Mac OS. When you have a file and you delete it, okay? Does it disappear from your computer?
No.
Looks like, right? Because you cannot find it. You put search, you will not find it, right? But do you think the file has been removed totally? No. Yeah, you can go to the trash can, but what if I delete it from the trash can? Can I still recover the file?
Yes.
Of course, there is tons of software out there that allows you to recover files. That's why when you tell your old computer on eBay, then you figure, why is my credit card stolen? Because some people store in files their credit cards, and when somebody buys the computer, the first thing they do is they do a recover all files. And they try to look for sensitive information like that. People are very stupid, people do that. Right? Because the file in the hard drive is something similar. hard drive. I'll make it simple. Okay? Imagine each of these is a sector, right? At the beginning of the sector, you have a flag, 0 or 1, in each of these sectors. 0 means the sector is free. 1 means the sector is taken. So if I save a file that uses 2 sectors, the file part 1 will be here and the file part 2 will be here. In here we have a 1, in here we have a 1. And all the zeros and ones of the file are here and all the zeros and 1 from the file are here. When I say delete the file, all Windows does, or Linux or any operating system, is change this 1 to a 0, change this 1 to a 0. But the file is still there. When does the file get really lost? When you take another file and save it there. I create a file fx and I save it, and that file happens to use these 2 sectors. So fx will go here and it will be 1 and 1. So now if I want to recover something, all I can get is fx. I cannot get that one anymore. Got it? And that's the same idea here. I'm saying 7, size 1, right? If I call push will insert on this position, on 1, right? If I say push 13, now 13 is going to come here and it's going to be 2. So it's the same idea. Got it? Got it? It's the same idea. We are saving effort. Why would we erase this if this guy can indicate me already if that's valid or not? Is that clear?
Yeah.
So what do you do in computers to avoid problems? We call it the military formatting, right? The military formatting method. They create a bunch of dummy files to populate the whole hard drive, and then erase it, and they repeat it like 2 or 3 times to make it even more secure. So what happens? After they have really filled the whole hard drive, and they deleted everything, if you want to recover something, you're going to recover those dummy files, because the written files were already overwritten. Got it? How many people do that? 1 in a million, right? Yeah, sure you do. Yeah, but yeah, most people don't do it. Most people don't do it. You can make it now. Okay, guys. So, let's try our stack. This stack, my stack, this one is stack. Oh, display the capacity of the site. That takes time. Okay. Well, let me make a small stack. So what happened here? I can start putting numbers, right? Push. What happens if I do pop here? Can I do pop here? Can I do pop here?
No, you don't have.
How do I get the element on top?
Pick.
Pick, right? But without, that will not remove the element. That will just take a look at it, right?
Yep.
So what will happen here? I'm going to try to solve. That's going to return what? Minus 1 because the stack is empty, right?
Return 1.
Correct? It should show an error, right? Okay, the stack is full, sorry. Element on top is 1. Okay, I think I didn't put an error for when the stack is. I should put a message here, right? Something like before returning. I should put something here like. and then 7 is not gonna fill in because the stack has capacity 3, right? So I'm gonna show an error saying stack is full, sorry. And then element on top should be 1 because 1 was the last valid insertion. Got it? Now,
Is that getting the one from the bottom or one from the top?
do I have a 1 on top? Follow the drawing. Draw this. Right? Capacity is 0, 1, and 2. Right? Because
Right.
this is 3, right?
0, 7.
So you push 2. Right? You see? The pop is not going to work because it's empty, right? I say push 2. So 2 comes here. Then I say push 4. And then I say push 1. And then I say push 7. I cannot push anymore. So I don't do, 7 does nothing.
Oh, I thought it went backward this one. I was thinking 2, like 7 to the bottom, 1.
7 will not be inserted because the stack is already full.
Huh?
7 will not be inserted because the stack is already full.
Right, but I was thinking of it down. I was thinking of 2, 4, 1, 7.
Remember, stack is last in, first out.
And then I think 3.
Stack is last in, first out. I have an eraser. Anyway, it's being filled out like this. Always draw the stack like that. 2, 4, and then 1. Right? Position 0, position 1, position 2. Right? Correct? No, 7 cannot be inserted. If I do peak will check who's on top of the stack. 1. What's the last one that was inserted? Let's start playing with some couple of operations. Let me make this stack a little bigger. 5.
Message received.
What am I going to print now? Can you guess? You just start playing here. Start playing with this one. Here's the Virgin stack. Capacity 5, right? Right? You say push 2. So far so good? Then you say push 4. Then pop. If you want just to do it graphically, you can delete it if you want to. Just graphically. But you know it's still there. Right? I'm just going to delete it so that when the push comes, you see that it's going to take that spot. But you know physically it's not going to be deleted. Right? Just do it like that for drawing. Then you say push 1. Then you say pop and pop. Pop, pop.
Push them.
And then push 7. This is how your stack looks at the end. If you're capable of doing that, of analyzing and being able to understand that, you're a big advantage already. Okay?
Now, what does it print out, the value, spot 1?
Sorry?
Spot 1, what will it print out? You said the value's still there. The
Wait,
value-
can I ask you, Darlene, yes, can I ask this spot 1?
I mean, if you say the number 4 doesn't get deleted, but it still stays in there, does it?
Yes, but that doesn't really, that's something not of your business, you don't care about it, because all you do is push and pop. How are you going to actually get another position 1? Is there a way for you to actually go on a position 1? No, pop will take the 0, because that's the only one valid now, 7.
If you want to print out the value of what index 1, which is item 4, that's what it used to be.
Oh, you can try. You can try, but it's going to bring more confusion than help. Why would you care about it?
I'm just curious, because you said it's still a memory.
Do it after class if you want. I don't want to do it here because I'm going to confuse the video. Okay? You can test it if you want. You make, like, you can make a mental. You're not supposed to do that. Otherwise, you make the whole concept here stuck. Okay, and then you care with the position. Yes. Sorry. Oh, eraser? Oh, thank you, man. So, guys, is this clear? Yes? Yes, sir.
I just want to look over that one bit. I understand the first one, but
Right, one at a time, please. Yes, sir.
I understand the first part that you said, but I just want to make sure the second part. So the second part meaning what you just did now.
Mm-hmm.
That you start off with 2, then 4, but then you did a pop after that, right?
Yes.
Get rid of the-
Yeah.
Therefore, you remove the 4.
So remove the 4. Alright.
So what you have now is just a 2.
2. And that's it.
And then you push 1.
And then you push 1.
So now you have 2 and 1 on top.
So
And then,
So 2 and 1.
and then you're doing pop, you remove 1. And then you're doing pop, again, you remove 2. The stack is empty. Right? These 2 guys.
But it still has the memory inside of it.
Yes, they're still there. And then you push 7. So the 2 that was there is going to be written with a 7, right? Now that you're talking about that.
So the 7
It's the only one that is there. Yes. Yes, sir.